Here's a second example. Now let's play with three-dimensional vectors. Find the angle between say 1, 0, 2 and 1, negative 2, 0. So suppose we're given these two vectors. Can we find the angle between them?
90?
No, if it was 90, then their dot product would be 0, but it's not, right?
Oh, yeah.
Yeah, but that was a good guess. You might just try that, but unfortunately, that's wrong. All right. Because I'm not allowing calculators, it will turn out that the answer can only be represented as cosine inverse. If we had a calculator, we can actually find the approximate value. But on the exam, when such questions are given, I'll be asking, express the angle as cosine inverse of some value. Okay, so let's do that. All right, I'll take the dot product because that's the only thing I know what to do. Okay, what's that? That's 1 times 1 plus 0 times negative 2 plus 2 times 0. So what's the dot product? 1. So we got the dot product using this formula. But what has this? What does this have anything to do with the angle between? Why are we doing this? Do you have any ideas? Yes?
Well, that first formula, the dot
The
product,
first formula
the dot product.
has the angle between it in there, right? Okay, good. So here's what we will need to do. We're going to say that the dot product between 1, 0, 2 and 1, negative 2, 0 is equal to the norm of the first times the norm of the second, and then cosine of the angle between. But I know the left side. I know that this left side is equal to 1. So we have 1 equals to the norm of these two vectors times the cosine of the angle between, and I can even find the norm. How do you calculate the norm in 3D? Same thing. It has square root 1 squared plus 0 squared plus 2 squared times 1 squared plus 2 squared plus 0 squared. I'm omitting the negative because if you square the negative, it's positive. Cosine of the angle between. So 1 is equal to square root of 5 times square root of 5 times cosine of the angle between. That gives you that 1 is equal to 5 cosine theta, which says that cosine theta is equal to 1/5. Therefore, theta is cosine theta is 1/5. This is not one of those special values, right? The special values, they all look like this. 1, 2, 3. So if it was either one of these three, or maybe 1 or 0, then we would know. But here, 1/5 is not one of those. So we can only express it by using cosine inverse, right? So you can only say that theta is cosine inverse of 1/5. Okay. Just out of curiosity, let me borrow this. Thank you. So if I do cosine inverse of 0.2, then I get. Oh, okay. So it was in scientific notation, so I was a little puzzled. Okay, so it's 78.4 degrees, 46 degrees. So that's the approximate. And if you think about it, this is pretty impressive. I mean, how would you know the angle between these two vectors? You can draw them definitely. 1, 0, 2. What's that? That means you're going one step in the x direction and 2 steps up. So it's a vector that's going that way, right? And what's 1, negative 2? 1 and negative 2 means actually the opposite. So it's a vector that's like that. So basically, I have a vector that's pointing that way, another vector pointing that way. And I'm trying to figure out this angle. It will be hard. If you try to do it without the dot product, you will have to use some kind of trigonometry. And I guess you will probably need to use the cosine law at some point. But using the dot product is much better. So you can see the usefulness of the dot product.